Hello students, myself Aman Bharti, PGT Physics from Kendriya Vidyalaya 3 BRD, Chandigarh. In today's lecture of units and measurement, we will study about need of measurements, unit of measurement, system of units, SI units, and fundamental and derived units.
What do we understand by measurement? Physics is a science of measurement. A measurement is a quantitative description of one or more fundamental property compared to standard. This standard corresponds to exactly one unit of quantity. As you see, the standard of length, which corresponds to exactly 1 meter, is the distance travelled by light in vacuum during a certain fraction of second. The measurement of a quantity is mentioned in two parts. For example, 5 meter. The first part 5 gives how many times of standard unit, and second part m gives name of unit. The numerical value of physical quantity is inversely proportional to its unit. For example, centimeter is smaller unit compared to meter, and 5 meter equals to 500 centimeter. We can see that the larger number is associated with smaller unit and the smaller number is associated with larger unit. If N1 and N2 are numerical values of physical quantity in two different units, say U1 and U2 respectively, the measure of physical quantity depends upon system of units used. Then N1 U1 will be equal to N2 U2. Need of measurement. Measurement is that operation by which we can compare a physical quantity with a unit chosen for that quantity. In science, during experiments, we have to take readings. Thus, all these experiments require some measurements to be made. During the production of mechanical products, we have to measure the parts so as to find whether the part is made as per specifications. Thus, measurements are necessary for production and quality control. Old methods of measurement. In ancient times, to measure lengths, units used were a finger, a palm, a span, cubit, foot, yard, fathom, furlong, etc. For example, one finger was taken equal to 1 digit, 4 digits equal to 1 palm, 2 palms equals to 1 span, and 2 spans equals to 1 cubit. But all these standards may vary from person to person. Hence, these units and standards were non-reliable. Types of measurement. There are two types of measurement: direct measurement, indirect measurement. When measurements are taken directly using tools, instrument or other calibrated measuring devices, then the measurements are called as the direct measurement. For example, measurement of length of table by meter scale. Also from figure, we can see that vernier caliper is used for measurement. Indirect measurement. When measurements must be done through a formula or other calculations. For example, measurement of radius of earth. Also from figure we can see that an application of similar triangle is used to determine the lengths indirectly. Units of measurement. A unit is a selected magnitude of a physical variable in terms of which other magnitudes of same variable can be expressed. For any measurement, a number and a unit is required. For example, when we say that time is 5 seconds, then we mean that the set time is 5 times a standard time called 1 second. Measurement without units has no meaning. Now there are some criteria for selection of unit. The selection of unit depends upon magnitude of quantity under consideration. For example, measurement of diameter of rod, millimeter is used. For measuring height of a tower, meter is used. For measuring distance between two cities, kilometer is used. For measuring distance between two stars, light year is used. This indicates that when magnitude of measurements increases, then the unit used for measurement should be larger. Accuracy of measurements. The unit should be neither too small nor too big in comparison with physical quantities to be measured. Accuracy of measurement also influences the selection of units. For example, from first figure we can see that in construction of room, where accuracy is not a major criteria, meter or foot are used as units. In second figure, for a construction of rocket, accuracy is important. So millimeter or micrometer may be used as units. So for accuracy, the unit used for measurement should be smaller. Characteristics of standard unit. A standard unit should be easily available. It should be non-destructible. It should not change with time and place. It should be of suitable size, means it should be neither too long nor too small in comparison to quantity to be measured, and it should be well defined without any doubt. Types of physical quantities. Physical quantities are those which are measurable. The physical quantities are classified as fundamental quantities, derived quantities. Fundamental quantities. Those quantities which do not depend on other quantities for their measurement. The units of fundamental quantities are called fundamental units. For example, mass, length, time are measured in kilogram, meter, and second respectively. Fundamental units can neither be derived from one another nor they can be further resolved into simpler units. Derived quantities. Those quantities which depend on two or more other quantities for their measurement. The units of derived quantities are called derived units. For example, velocity, force, pressure are measured in meter per second, Newton, and Pascal respectively. System of units. A complete set of units which are used to measure all kind of fundamental and derived quantities is called system of units. Some of the commonly used system of units are as follows. CGS system. It is based on centimeter, gram, second as fundamental units of length, mass, and time respectively. FPS system. It is based on foot, pound, and second as fundamental units of length, mass, and time respectively. MKS system. It is based on meter, kilogram, and second as fundamental units of length, mass, and time respectively. Basic SI quantities and units. SI is the abbreviation for System International D Units, or called as International System of Units. There are 7 basic SI units and 2 supplementary units. Base quantities and their units. Length has a unit meter, mass has the unit kilogram, time has the unit second, electric current has the unit ampere, temperature has the unit Kelvin, amount of substance has the unit mole, and luminous intensity has the unit candela. Now we will discuss definitions of SI units. Starting with the SI unit length and its unit meter. As we know that the speed of light is 3 into 10 to the power 8 meter per second, which is the approximate value. Actually, the distance covered by light in vacuum in 1 second is exactly 299,792,458 meters. So, 1 meter is covered in 1 by 299,792,4258 of a second. So, meter is defined as the length of path travelled by light in vacuum during a time interval of 1 by 299,792,4258 of a second. Definition of kilogram. Previously, the kilogram was defined as the kilogram is equal to the mass of international prototype of kilogram made up of platinum iridium alloy cylinder kept at International Bureau of Weights and Measures at Sèvres near Paris, France. In 2019, a new definition is adopted by taking the fixed numerical value of the Planck's constant. Planck's constant is a physical constant, that is the quantum of electromagnetic action which relates the energy carried by photon to its frequency. The value of Planck's constant is approximately 6.63 into 10 to the power minus 34 joule second. So kilogram is defined by taking the fixed numerical value of Planck's constant h to be 6.62607015 into 10 to the power minus 34 when expressed in the unit joule second, which is equal to kilogram meter square per second, where the meter and second are defined in terms of c, which is the velocity of light, and del v cs, which is the frequency of transition of electron in cesium atom. Definition of second. From the atomic structure of cesium, we can see that the electron oscillates between two hyperfine levels and we will always get waves. These waves have some characteristics. The basic characteristic is the time period. If these waves covers exactly 9192631770 periods, then it is called as 1 second. So 1 second is defined as the duration of 9192631770 periods of the radiation corresponding to the transition between the two hyperfine levels of the ground state of cesium-133 atom. Definition of ampere. The force between two parallel wires can be used to define ampere. When the magnitude of force per unit length between two long parallel wires that carry identical currents and are separated by 1 meter is 2 into 10 to the power minus 7 Newton per meter, then the current in each wire is defined to be 1 ampere. Definition of Kelvin. Before discussing the definition of Kelvin, we should understand about triple point of water. The triple point of any substance is that temperature and pressure at which the material can coexist in all the three phases, that is solid, liquid and gas, at equilibrium. At temperature 0.01 degrees Celsius or 273.16 Kelvin and atmospheric pressure of 611.2 Pascal, the water can exist in all the three phases. Let us choose a scale from 0 Kelvin to 273.16 Kelvin and divide it into 273.16 equal parts. Then each part will be equal to 1 Kelvin. So, the Kelvin, which is a unit of thermodynamic temperature, is the fraction 1 by 273.16 of the thermodynamic temperature of the triple point of water. Definition of mole. A mole is the mass of the substance which contains the same number of particles as 12 gram of isotope carbon-12. These particles could be atoms, ions or molecules. 12 gram of carbon-12 contains 6.02 into 10 the power 23 atoms. This number is called as the Avogadro constant. Definition of candela. Before discussing the definition of candela, we should first understand about the term steradian. Steradian is a unit of solid angle of a sphere. If we take cross section of sphere along diameter, it will be a circle. 1 steradian is the angle having radius 1 unit and arc of 1 unit. Keep a candle or bulb of frequency 540 into 10 the power 12 Hz at the angle of 1 steradian. Light has different frequencies, so this frequency corresponds to yellow light. The light or energy in 1 steradian is called candela, or when the energy is 1 by 683 watt in the angle of 1 steradian, then the luminous intensity is called 1 candela. So, the candela is the luminous intensity in a given direction of a source that emits monochromatic radiation of frequency 540 into 10 the power 12 Hz and that has a radiant intensity in that direction of 1 by 683 watt per steradian. A normal candle emits roughly 1 candela. A 100 watt incandescent light bulb emits about 120 candela. Supplementary quantity and SI unit. Plane angle. It is defined as the plane angle subtended at the center of a circle by an arc equal in length to the radius of the circle. Plane angle equals to arc upon radius. The basic unit of plane angle is radian. Solid angle. It is the solid angle subtended at the center of a sphere by a surface of sphere equal in area to that of a square having each side equal to radius of sphere. It is given by solid angle equals to surface area upon radius square. The basic unit of solid angle is steradian. Coherent system of units. It is a system of units based on a certain set of fundamental units from which all derived units can be obtained by simple multiplication or division without introducing any numerical factor. For example, MKS system is a coherent system of units in mechanics. All derived units in mechanics such as area, velocity, density, acceleration, force, etc. can be obtained by multiplying or dividing of fundamental units of mass, length and time. Advantages of SI system over other system of units. SI system of unit is a coherent system of unit covering all branches of physics. It is rational system of units. It is a metric system. It is internationally acceptable system of unit. The base units are invariant and easily reproducible. There are some prefixes of powers of 10. These are the common prefixes which are used with units. They are in multiples of 10. For example, the prefixes for units having value less than 1 are deci, centi, milli, micro, nano, pico, femto, atto. And the prefixes for units having values greater than 1 are deca, hecto, kilo, mega, giga, tera, peta, exa. For example, 1 mega ohm equals to 10 the power 6 ohm. 1 kilometer equals to 10 the power 3 meters. 1 decagram equals to 10 gram. 1 milliampere equals to 10 the power minus 3 ampere. 1 microvolt equals to 10 the power minus 6 volt. 1 nanosecond equals to 10 the power minus 9 seconds. 1 picofarad equals to 10 the power minus 12 farad. And 1 centimeter equals to 10 the power minus 2 meter.